Question number 5. A pith ball A of mass 9 into 10 to the power minus 5 kg carries a charge of 5 microcoulomb. What must be the magnitude and sign of the charge on a pith ball B held 2 cm directly above the pith ball A such that pith ball A remains stationary? Okay, so suppose this is pith ball A and this is pith ball B, which is held right above the pith ball A, and the distance between these two pith ball is 2 cm. Okay, now the charge of the pith ball A is given, charge and the mass. So let us suppose m1 is the mass of the pith ball A, which is 9 into 10 to the power minus 5 kg, and charge is q1, which is 5 microcoulomb, that is equal to 5 into 10 to the power minus 6 coulomb. Now to remain this A pith ball stationary, it is possible that the charge on B pith ball is negative. It has to be negative, right? So the mass m1, so obviously the weight of that ball will act downwards, which is m1g w, and the charge, let us suppose the charge on B pith ball is q2, and to remain A stationary, q2 has to be negative. Okay, so the Coulomb force will act in this direction. That means the Coulomb force on A due to B would be, let us suppose this is FAB. Okay, so this FAB and the weight has to be equal to each other. So FAB is equal to m1g, and we know from Coulomb's law F is q1 q2 by 4 pi epsilon naught r square is equal to m1 g. Now r is given, r is 2 centimeter, which is equal to 0.02 meter. Now from here we have to calculate q2, the charge on the second ball. So m1g into 4 pi epsilon naught r square divided by q1. Okay, now m1 is 9 into 10 to the power minus 5, g is 9.8, and 1 by 4 pi epsilon naught is 9 into 10 to the power 9, which would go here, 9 into 10 to the power 9. R square is 0.02 meter, and q1 is 5 into 10 to the power minus 6. And after calculating this, we'll be getting 7.84 into 10 to the power minus 12 coulomb. So this is our answer. So the first is the magnitude of the charge is this 7.84 into 10 to the power minus 12 coulomb, and the sign of that charge would be minus. Question number 6. Two identical metal spheres having equal and similar charges repel each other with a force of 103 Newton when they are placed 10 cm apart in a medium of dielectric constant 5. Determine the charges on each sphere. So let us assume the charges are Q. So let the charges be Q. And here the force is given, that is 103 Newton. So the force is 103 Newton. The distance between these two charges is 10 centimeter, which is 0.1 meter, and the dielectric constant kappa is given, that is 5. Now we know that the force in medium is equal to the force in vacuum divided by dielectric constant. Now this F med medium is equal to We know that force in vacuum is 1 upon 4 pi epsilon naught q square by r square. Now this is given, which is 103 Newton. 1 by 5, dielectric constant is 5, and 1 upon 4 pi epsilon naught is 9 into 10 to the power 9. Charge is q square divided by r square is 0.10 square. So from here, q square is equal to 103 into 5 into 0.1 square divided by 9 into 10 to the power 9. So from here, q square is equal to, we'll be getting 0.57 into 10 to the power minus 9, or 5.7 into 10 to the power minus 10. So from here, q is equal to square root of 5.7 into 10 to the power minus 10, which is equal to 2.38 into 10 raised to the power minus 5 coulomb. So this is our answer. So the charge on each sphere would be 2.38 into 10 to the power minus 5 coulomb. Question number 7. The distance between the electron and proton in hydrogen atom is 5.3 into 10 to the power minus 11 meter. Determine the magnitude of the ratio of electrostatic and gravitational force between them. Okay, so the distance, that is r, is given, which is 5.3 into 10 to the power minus 11 meter. Now the electrostatic force is equal to 1 upon 4 pi epsilon naught charge of the electron, which is minus c, and charge of the proton, which is plus c, divided by r square. And the gravitational force Fg is equal to g, which is gravitational constant, into mass of the electron into mass of the proton divided by r square. Now take the ratio of electrostatic force and gravitational force. Just take the magnitude only. So Fe by Fg is equal to 1 upon 4 pi epsilon naught E square divided by R square divided by G ME MP by R square. That is equal to 1 upon 4 pi epsilon naught E square by R square into R square by G ME MP. R square will cancel out with each other, and we'll be having 1 upon 4 pi epsilon naught E square into 1 upon G ME MP. Now the values of this E square, G, ME and MP, that is also given. I forgot to write. So first, 1 upon 4 pi epsilon naught is equal to 9 into 10 to the power 9 Newton meter square per coulomb square. Then E is 1.6 into 10 to the power minus 19 coulomb. G is, that means gravitational constant, is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Then mass of electron is 9.1 into 10 to the power minus 31 kg, and mass of proton MP is 1.67 into 10 to the power minus 27 kg. Now we have to substitute all the values here, and it would be 9 into 10 to the power 9. E square is 1.6 into 10 to the power minus 19 square divided by 6.67 into 10 to the power minus 11 into 9.1 into 10 to the power minus 31 into 1.67 into 10 to the power minus 27. And after calculating this, the answer would be 2.27 into 10 to the power 39. Okay, so the the magnitude of the ratio of electrostatic and gravitational force between them is 2.27 into 10 to the power 39.